Hello and welcome everyone to today's webinar. Thanks a lot for taking your time. I'm Harold, the CEO of Visplore, and I'm very excited to show you some highlights of the new Visplore version 1.6. So let's look at today's agenda first. Before we come to some bigger use cases, I want to draw your attention to some improvements which are helpful in the daily work. These improvements span data management, the story feature of Visplore, and much more. And then we will also show you some exciting new use cases with live demos. We will demonstrate you, for example, how to monitor the compliance of assets to vendor-specific charts. And you will, for example, also see a very extensive use case on joining data sources for analyzing batch data. If you have questions, please post them by clicking the Q&A button in Teams, where you can write to that section anytime. In German, the button is called F&A. We will try to answer as many questions as possible in the end. So let's get started with some usability improvements. One thing that you have requested over and over is the ability to rename variables. And here it is. So consider this practical example. Assume you have imported some variables from a historian such as pi, and the names are simply too long. Now you can easily improve the readability. And here is how this is done. So here in this image, we see quite long variable names. And what we can do is we can switch to this dialog, and here we can say we just rename them to give them shorter names. And do this with the other variables as well. And when we confirm this, we can also see basically which was the original name of this variable from the data source. And when we do this, the names are shorter. So also here, the tooltips look now cleaner and the axis of the scatter plot as well. So this renaming works for data you import from a data source, as well as for variables that you may have defined yourself based on a computation. You cannot only rename variables, but the new version also introduces a central place for managing all your computed data. So if you click this Edit button in the toolbar, marked in red here, you see all computed variables, conditions, and classifications of your data. This makes it much easier to keep track of them, and it allows you to edit their definition, rename them, clone them, or delete them. And also conditions have seen new extensions. So just as a brief recap, conditions are a way to specify in Visplore that you're interested in a certain state of the data. Here in this image, we see, for example, a condition based on this interval here, on this variable, to get all the times when this variable is within a certain range. Now, this extension makes it much more easy to deal with noisy data. It's possible now to include short gaps in the results of a condition. For example, if you look at this image, you see some periods where the process state is more or less consistent, but you also see that the data is noisy and there are some short spikes going down that interrupt the process state from time to time. Now, let's see how we can still get useful data segments out of this. If we just define the condition like this, we see that we have captured everything that is within this interval, but not the spikes. However, if we edit this, we can now specify to include interruptions, and in this case, include everything that's less than 5 hours. And now when we revisit this condition, we see that all the short spikes are included there as well. So why is this helpful? If we say we want to compare all these times, which we can easily do using the compare selected events feature, we have now a short list of just 4 different intervals corresponding to the intervals you see in the time series view. Now, just for comparison, if we change this and say we do not include the interruptions, we would end up with dozens of short intervals. So you see the list here in the pivot table is now much, much longer. And actually, many of them are very short and not really useful. So it's a way to make your work with conditions more robust towards outlier and data noise. As another extension of conditions, they may now optionally include the filter. Why is this necessary? One use case is to define a label differently for different classes of the data. So in the example that we will see in a second, we have 2 different products and we want to define a label outlier. See how this looks like. So here we have 2 different products, and first we set the filter on product B. Right? And now we can specify what actually means an outlier here for product B. And we see when opening this create label dialog, we see that there is a new entry called that we limit this definition only to product B. So this interval now only applies to product B. If we now switch to product A, we can set different intervals. So for example, in this case, we can even specify 2 intervals and also label them as outliers. In this case, the intervals apply to product A. And if we look at both products, we see now all outliers that we defined. And can even change that. So when we change the definition of the outlier, we are asked whether we would like to change it for product A or for product B. In this case, now for product A, can change the definition here and update it accordingly. Okay, so the previous feature may be already quite advanced. So let's get to something simple for relaxing the brain a bit in between. We also tried to improve the look and feel at several places of Visplore. And one place that has been criticized in the past sometimes were the tooltips. They look quite different now. For example, as you see in this image, time series are distinguished by color in the tooltip. And some other improvements in order to avoid the tooltips become too big. Now, for an exciting feature that's actually one of my personal favorites. Scatter plots are a very commonly used feature of Visplore. And now you can actually improve them by specifying an image file that is used as a background, giving context to the data that you see. And this actually opens up some exciting new use cases. For example, you can use image files for indicating process regions. So imagine you have a valve and you want to see if its operation is compliant with vendor specifications. So let's see how you could set up something like this in a live demo. First, let's start by just looking at the image. So what is necessary to get something like this? Actually, everything that's necessary is some image that could be stored as a PNG, for example, as we have in this case. And this is something that we can display in the scatter plot. So how can this be done? Let's switch here. Here we see the data from the valve over a few months. We see that we have 4 different tags: flow rate, monthly water usage, valve opening, and water temperature. Now, let's see, we say we want to get to this chart showing the operation regions. First, let's open the scatter plot. Now, in order to get the axis of the scatter plot parameterized, we can now use this do this directly here in the axis. It's also a new feature. Just clicking here, we can say select variable and select the flow rate here. And we just do the same thing here. Get the valve opening, and we already specified the chart plotting valve opening versus flow rate. This already stays this way, so it's not yet coupled with whatever we select here. So we see that here we still have the water temperature while we're looking at the flow rate here. But let's switch to the flow rate altogether. And now let's get to the background image. Adding the background image is possible by just clicking here at the option and say define image background. In this case, let's load this image. And now we need to configure it a bit. First is we might want to be a bit less intense, so something like this. And then we have to specify what coordinates the edges of this image correspond to. So in this case, the left edge of the image corresponds to a valve opening of 0 and the right to a valve opening of 100%. And for the y-axis, the top corresponds to a flow rate of 2200 and the bottom a flow rate of 0. Okay, now we can close it, and now the image here is correctly aligned with the data. We can zoom in, for example, we can go here and see that we zoom both into the data as well as to the image context. We can also do things like selecting data, as you know from Visplore. So for example, we could do a first rough selection of data that's falling outside of this main operating region. And doing just something like this lasso selection here. And then we see that this, for example, happens more often towards the end of the data. Okay, so this was step number 1 in this use case, how we can set this image. Actually, I want to take this use case a bit further, because to really make this a kind of an operation analysis, something like that might not be sufficient. But what you can do is actually assume you have given the upper and the lower boundary of this operating region as a kind of polyline in this form. So here basically we see the values of the valve opening and the corresponding values of the flow rate. Then what we can do is to set up something like this. I prepared here a short analysis of 2 story pages. So let's look at the first one. It's the same data, it's the same background image here, but it already classifies the region as being either the shutdown ones in gray, the normal ones in green, the ones that are too low in red, and the ones that are too high in purple. And here immediately we see that this is basically changing over time. So here we see that at some event, obviously here, something occurred that caused this dependency to drop and get outside of the specified operating region. Just one more example. This basically shows events where we are out of specification for 12 hours or more. So basically what we can do here is just click through the events, see the corresponding data. In this case, we see the flow rate here in blue and the tolerance limits according to the specification on top. And we see also the corresponding data here in the scatter plot, always together with the graphic. Just can browse the events this way. All right, with this, let's switch back to slides. So there is also another use case of the new background feature. When you have multiple assets, you may want to show them in a spatial context. So in this image, for example, there are 4 machines. The location within the shop floor per production site is shown in this map. Yeah, so basically think of this as a kind of a map of a shop floor. And here we see those 4 locations of these 4 machines, distinguished by color, so that we can easily correspond them with data, for example, here in the time series view. And an advantage of having it this way is that it's easy to select assets using tools like rectangle selections. And also, if we select data here in other views, we would see the corresponding asset pop up as a point here on this map. So this works in both directions. Okay, so now for the next next improvement. In the previous live demo, we've already seen an example of an operational story. Pages there are used for analysis templates that can just be opened on the most recent data to give you some results. And for such use cases, we added another very helpful feature, namely now pages can be linked so that they share the same data. This means if you add a variable for one page, they also can become available on the other pages. Same thing for labels, or if you cleanse outliers. To make this a bit more concrete, let's look at this example here. So here we have basically an analysis comprising 4 pages. We have 6 tags imported from a Pi system, and we see for the variable indicating how long within each month the process stays in a certain value range. Okay, now assume that we would need another tag. How can we do this? We can just say we want to add this tag also from the Pi system. Say we want to add tag number 12. And this tag is fetched and we have it now. So we added the tag number 12 here. And if we switch to it, we see that there are some outliers that we might want to cleanse. We do some interpolation of these values. Okay, and now we added one more tag and we cleansed it. So we can switch over to another page and we see that here tag number 12 is present as well. And if we visualize it, we also see that the cleansing of the outliers has been taken over. And if we want to use, for example, this scatter plot now to go further, we can just define a label here. This part of the process where this tag number 12 is close to 0. So let's call it down. Now we can just switch over to the next story page. This page shows all events where 2 tags show some spikes. But we see that this corresponds partly to the time when there are downs on tag number 12. So we can just filter now on the label we just created and get into something like a workflow here. So brief, you see that when you add new variables on one page or labels or data cleansing, you can continue working with them on the other pages. This facilitates some things. Maybe as a comment here, It's also possible, as it was before, to have the pages separated from each other. So if you want the data of one page not affecting the other, you can do this. Yeah, that's possible. But when creating operational stories, it actually makes things much easier to have all of them sharing the same data. Okay, and for the next highlights, I hand over to my colleague, Thomas.
All right, thanks, Harald. Hi, everyone. How's it going? I'm Thomas, CTO of Visplore, and I'm going to present to you now a few improvements regarding segmenting time series data into events. So events like process operations, plant startups, or batch phases in chemicals. And we've already had some ways of segmenting the data before, like the pattern searching. But the pattern searching was very useful for segmenting patterns of the same length, essentially by the similarity. And I show you now two ways where we have overcome this, and it allows you to search patterns of different lengths as well. So the first thing I want to show you here is the possibility to define a pattern search by two patterns, actually, by one that defines the start pattern and one that defines the end pattern. And in between, anything can happen. It would still be found from here to here as a segment. So to make this a bit more clear, let me show you in this quick video. This is data from a milling machine. Zooming into a few milling operations here, we already see they can have different shapes and lengths. So let's select the start pattern of such a milling and the end pattern. And as we search for that, similarly to before, you get a dialog that lets you set what is still similar enough. So with just one click here, we see, for example, we have extracted 234 milling operations, and it's quite evident here already that we have also included those that are longer than the bulk of the patterns here. Also, you see, for example, there are new parameters down here for a minimum and maximum duration of the pattern. This is also quite useful to give it a reasonable context in which to search for this. Okay, so that's an extension of the pattern searching, which works very well if you have at least some very distinct start and end patterns to search for. But nevertheless, it's quite a quick and graphical way to define the patterns. And for something even more explicit and more exact, we have added formula-based segmentations, where you can define strict rules when a segment starts and when a segment ends, even if you have no pattern at all. Okay, so take this example here. This is from a coal power plant, and we're interested in the startups of that power plant. So we see here, this plant is off and then it's turned on. And the red ones here are two such startups. And the startups can be defined here by a rule like when the cooling water exceeds 300 units of being pumped in, we start the startup. And when the power has reached 32 units or above, the startup is said to have ended. Using these rules, you would see that you get the startup patterns extracted, even though they're quite different in length. And this I want to show you now in a live demo, as well as computing some KPIs and summaries on these segments afterwards in a new way. But let's start with this segmentation first. So I'm jumping over here to Visplore, where I have already loaded this data set and entered the cockpit for pattern search and comparison. Now, this is now your new cockpit for all things segmentation. Okay, so you don't have to think, where do I segment, when do I switch? No, pattern search, cockpit, and then here you can define the segmentations nicely. So we see here this net power time series of the plant, and let's zoom in into around one of these startups. So here the plant is down, and here it's turned on. We can include the cooling water. This was one of our criteria, right? And we see here the period from here to somewhere here should be extracted. Now, how do we do this? We declare the intent to segment. So up here, choose, and you see all of the segmentation types in one neat dialog here. So pattern searching would also be here. New is this segmentation rule with a start and an end trigger, marking start and end of our patterns. Using this, we see our formula editor. Why is this? Well, because this segmentation actually has quite some parameters you can adjust. but you don't need them. So to achieve simple things like we want to do here, you can do it as follows. We define here our start and our end criteria using the variable names. So I1 is our power, I2 is our cooling water. We said, and this is also how usually the engineers think about this, we said the cooling water over 300 units is when the pattern starts, and the net power being over 32 units is where the pattern ends. Right, let's compute this. So this is going through the data, marking up the segments, and you can give it a name, plant startups. And then we see 5 segments were found. Here we see when to when they lasted. Here we see them overlaid. And down here we see them over time. Now that long one is a bit strange. Let's look at this closer. Well, the first ones, they look good, right? So this is how as expected. But this one, the cooling water goes up, but the power doesn't follow. So apparently someone decided here to turn the cooling water down. It was actually not a startup. But the problem is that with our rule definition, this until the next actual startup is marked. So what can we do? We cannot actually filter out this whole segment because we would lose that part. What we need to do is define kind of a termination criterion, like if the cooling water comes down, this is not a segment and we keep searching. And this is what we can do. We can edit our segmentation here. And as I mentioned, there are quite some parameters here you can use. And here for this termination criterion, we can use a discard parameter, meaning to discard the current pattern if the cooling water sinks again below 300 units. Okay, so like this. If you do this, then the search would say, okay, this is not one, keep searching, and then mark the last one correctly. Now, if you wonder which parameters you have here, every formula, also the segment by start and end, has here its documentation that you can open up and read with examples how to use that exactly. All right. And now that we have our 5 nice segments, we see them nicely overlaid. So far on the segmentation. Now, in such a use case in a power plant, a typical follow-up step would be to analyze the fuel consumption during the startups. And we have here coal, for example, that's being burned and natural gas. So if we take a look at these amounts or these quantities that are being burned here during the startup, we see in red the gas and in black the coal amounts. So a first easy thing we could do is summarize the total of amount used for every startup. This is easy because we can just turn on the sum as one statistic here. And then we see already the tons per hour and this norm cubic meters of fuel used for every startup. That was possible before this computation, but now we have added a feature to define your own custom KPIs per segment. So let's say, for example, we're particularly interested in the gas being used, and we want to know the duration between the gas starts until the coal starts here. Okay, so the duration from the red flank till the gray flank. To measure this for every startup is not a built-in statistic, but you can define it. And here you can say I add as a computation per segment a custom aggregate value. Again, I see the formula editor. I could use all the built-in formulas. And one that I want to use here in this example is the duration. That's a new formula here where you can measure things in time. Right. And what do we want to measure? Well, not the entire startup period, but actually we want to define a condition here, namely this time between red and gray flank. And how is this expressed? Well, the gas is larger than 0 from this flank onwards. So gas is I2 being larger than 0. And coal being below this here, below 5 units, let's say, because these you don't want to count, it's little edges. So let's say, and coal is below 5 units. This is our condition we want to track, to measure. And the unit of this you can also define should be in minutes, please. All right. And as we define this, duration of gas without coal is what we name it. This actually computes a new attribute here, which we can show as one point here. And also here, we see it now for every segment. We see how many minutes it takes between gas coming up until coal amount coming up. So let's just validate this briefly, looking at this one, 41 minutes between here. This is approximately 3:06 until here, 3:48. Yeah, 41 minutes difference if we subtract also these little hills. And that's shown as the blue point here. All right, so this was one example of computing custom KPIs from your segments, and this can be anything. And also in the workflow, you can use this now, for example, to correlate it with other parameters. So like KPIs correlated with some controlled operation parameters, for example. You can also save this as a template and use it every few days or weeks for the newest data, for monitoring this kind of KPIs, and also for reporting. Okay, jumping back to the slides. This was about these new segmentation methods. I will get back to segmentation in a minute as a part of the following use case, but I want to start this one differently. I want to describe another new feature we have regarding data integration, which is, it is now possible to combine multiple data sources via keys, okay, relational keys, which is a common way to enrich the analysis by some extra data. So for example, let's say we start out with process data from a batch manufacturing, like here. And we have already given the batch timings as something like exported event frames. For example, batch 1 lasted from 6 until 9:50. Product A was made. This has already been possible before to merge things over time. But now with the key merge, it would, for example, be possible to add quality KPIs per batch from such a table, where you can say, okay, based on the batch ID, you bring these together, allowing you to correlate quality information with aspects of the process data. Another example would be merging meta information about the product from another table based on this key. For example, what's the price currently per kilo of that product? Or when did we make this product for the first time in our process? Things like this. Okay, so merges on the keys without any time context are now possible. This is very common in databases, relational joins, right? And in Excel terminology, it's also often referred to sref or sverweis in German to do this kind of merge in your Visplore analysis now. And I would like to show you this in a live demo with data from batch manufacturing. And here we also join quality data to the process data for the purpose of defining some golden batches, so some corridors where the process data should be based on some good products we made based on the quality and shapes of the process data. You will see this. Okay, so we need to merge the quality to define such golden batch corridors. And for this, I want to switch over again to Visplore. So, okay. And I start this right from the beginning. We import the process data first from a time series historian, here, the OSIsoft Areva Pi system. So we import time here from 1 month last year. This, for example, would be one campaign of these products that we want to investigate in a 30-second resolution. The process data we have comprise pressures, flow rates, temperatures, but also batch IDs, phases, and products are given here as data already in the historian. If you don't have this kind of data in the historian, you can merge this also based on time, as we have shown in last year's webinar. You can watch the recording of that. But now, as we know, several companies have it like this. This would be our starting point from the process perspective. Let's import this. Again, it auto starts the pattern search and comparison cockpit. I have set this as my default cockpit here because we are going to segment here as well. We see the data here. This is batch data. So zooming in, we quickly identify different phases of batch, different batches, and so on. We can segment this data here as well. We don't have to do pattern searching and so on because we have the batch IDs. So we can directly define the segmentation based on this. And we see 41 batches have been made here. They're overlaid here. And if we spot something like an outlier here, we can simply select it and see immediately which batch was this. Aha, it was on the 8th of September. And here are some statistics. So that's not new, that was possible before, simply by segmenting by these batch IDs. But now we want to merge the quality for every batch. This is new. So we add a new data source up here. And in this case, we have the quality KPIs exported from a LIMS as an Excel file and save this as a CSV. So let's select this file here, the data. Here we see how this data looks. There is no time context here. We don't need it for this merge because we have the batch IDs and we have the different KPIs here per batch. Note that we could also do this for multiple assets at once. Yeah, so it's not limited to a single merge key. Right. Now we are asked, do we have a time axis in there? No. We are merging here by batch IDs. So we have to define which is actually the ID, the key. Right? So in the quality data, it's called batch. And in the PI data, it's called batch ID. These are mapped. And we can continue. We see 2 data sources are now here. We don't need to rasterize the data further for this because it's just the relational enrichment of the data. And doing this, we see that our KPIs have appeared here next to the process tags. Looking quickly at KPI number 1, how does this look? Let's zoom in. It means that during every batch, the KPIs are actually put here constant for that period of the batch being made. Okay. And we could also take a look here, for example, at a scatter plot where we show a KPI over time, for example. Okay, so this is essentially just a timeline, and we could correlate this KPI now with the flow rate by saying, what were those where the KPI was off the normal? How did the batches look like, right? A common question for process engineers here. So let's select vertically everything above a certain threshold. And you would see these high KPIs are achieved for some batches that look like this. And we could also take a look, for example, what the pressures were doing at the time and so on. Okay, so this is actually the simple correlation between the quality and the process data. Now, what you often need to do here is actually not just a visual correlation, but actually you have many process parameters and you want to see which ones actually are responsible when you have a certain deteriorating quality. So a root cause analysis or a deeper correlation analysis between the two. And for this, you might need to define some KPIs about the shape of your process data, which you correlate. And you can do this in Visplore. So let's, for example, say we care about the shape of this phase 1. How does the flow rate propagate in this phase 1 to the quality in the end? And for this, we can filter on the phase 1. So let's define phase 1. Okay, now we see all the 41 phase 1s aligned here nicely. Also, we could spot some outliers already. But now we want to correlate, let's say, for example, how long the flow rate is above a certain threshold. This could be one typical summary of every shape here. And we can do this by defining this summary or this feature here from a list of built-in things. For example, duration above a threshold. That's a KPI we extract from every curve. And we could show this now here over time. So every point here is now how long is this batch over 4 flow rate units. Changing the threshold here immediately updates this KPI. Okay. So now we have nicely summarized this shape by how long are we over 6 units, for example, and that we can directly correlate with our KPI. So KPI here is the quality. Remember, quality correlated with our duration above a certain threshold. You can also show that relationship here with the regression line if we want, and still see how this parameter affects our correlation. So why do we do this? To see relationships between process parameters that we have an influence on and quality in the end. And if we want to extract many KPIs, we can do this by means of built-in Visplore with this curve property definition cockpit, or with these custom KPIs we have seen in the previous use case. Okay, so defining the KPIs and then correlating them with your quality. And now I want to show you as the last part of this use case, how this quality actually helps us to define a golden batch corridor for the flow rate, and then to set up a monitoring template from this. So we see that this flow rate here has some variation, of course, and also the quality. We can say a golden batch here, just for simplicity, is when the quality is in a certain interval, let's say below 970, and the shape of the flow rate has to be in this corridor. Okay, so we define a query here, it has to run through this, and the quality has to be in this area. And from these, actually, we can define the corridor that we define as golden. How do we do it? We can show that corridor, and we can define it not by standard deviation, maybe in this case, but just by the maximal extents of it, and say this is the corridor we want to watch in the future. So the last thing we have to do is say, Visplore, this is our corridor to monitor, please. Okay, and the steps are two steps with some degrees of freedom, and I'm showing you this now. So the first thing, how you set this, is that you export this corridor as a file. Why as a file? Because then you can put it as an input to multiple templates and maintain it also. If the golden batch has to be readapted in 2 months, for example, it will be centrally updatable for all your templates. So exporting this as a file, select the path where I want to save it. This would be my file. Yes. And what is in this file? Well, actually, it's 3 curves. Here's the time. And here you see the curves as a signal. So what is your expected reference curve? What is the maximum of the corridor? What is the minimum of the corridor? Okay, 4 columns, and we will need these 4 columns. Saving them. Now we have them. And now the last thing we have to do is to set it as a reference for this in Visplore again. Okay, so let's show all of the curves again, not just the golden ones. And then we import this new reference. And this can be done here with importing a reference curve. This is it. Now we can reference the file. And now we see the formula editor for a last time here, because there are also some degrees of freedom we can use, but we don't have to. By default, it would just take the first column from our file, which is the reference curve. So let's just continue here. Call this reference for flow rate, that's fine. And now we have a new signal here. And when we overlay it with the flow rate, we see this signal contains the reference curve here for every segment. Okay, sometimes it's better, sometimes it's worse. And we could now quantify this difference also by some custom KPI again, like we did in the previous example. Or to finish this quickly, I can import also the tolerance corridors we have had by adding another reference curve here. The same file, remember it was just in the next column of the file, and specifying here that we take the column number 3. This is the upper boundary we have exported. This would be our upper tolerance limit for flow rate. Right, we see it and finish this, loading it once more for the lower. Lower tolerance. The name is irrelevant, I just. Right, and now you see here the nice corridor. Green is the reference, orange and blue are now the outers. You could make it red if you want. And we see how they behave in the corridor or not. And this is nice for visualizing, but actually we can now set this into an operational template. For now, for the brevity, I have just defined it for the phase 1. So what if we have more than phase 1, as we do here? Well, you see that we actually have the corridor here for phase 1. We could do it for the other phases and signals as well. But to save you that time now, I have prepared this already, and I jump over to such a template where it has been defined. So it's the same data set, but you see that for every phase, we have defined the corridor in red and the reference in green. Not just for visualizing, but actually, you can easily now select the non-conformity times whenever the actual data is running out of the corridor. And this is shown up here. We show here for every different product that is being made, like A, B, and C, how often we have a non-conformity per phase. So product A was non-conform in phase 1 4 times. Let's look at them. Yeah, here are the events. Okay, so this one was grass, and we see also how long they were outside and so on. Okay, so this allows us to inspect our problems from the last batches very, very quickly. And last thing, if we want to see all problems in one overview of the whole campaign, we can do this, see this nicely summarized here, and we could then have this as a result of a regular inspection of such a template. Okay. So this may be specific a bit for chemicals, pharmaceuticals, and so on, but you can use the same pattern also for monitoring machine operations, for changes, changeover processes, for plant startups, depending on different input conditions and so on. That's also why we made these true formulas, because then you can adapt it to complex scenes from the reality. Okay, that concludes the last use case demo that I wanted to give. The final mention I want to do here is some additional improvements, just to mention them. Data integration and data connectivity has been extended as well here. We have added a connector to the Aveva Historian, which was formerly called Wonderware. And you also can define rasters, the implementation, the interpolation methods and so on of the import. So it's actually quite flexible, like the Pi connector, for example, that's there as well now. Also, to our custom connectivity system, we have made extensions inspired by the feedback we got from you. And especially for the influx connector, which is just such a custom connector, we have made some things more scalable, and we have also made some other feedbacks that you report for influx as well. In general, the formula editor has received many new formulas here. One prominent example would be computations for frequency analysis. So it's possible to compute the dominant frequency or the response, the frequency response to a certain band from your time series data here as well, just to give you two examples here. And many additional ones were made for segmentation and computing KPIs per segment, as we have teased in the demos as well. And of course, there is still more. So you could visit our blog on the release, which you can find on our webpage in resources blog. There you can read all the details also with some images. Okay, I think that's it from the demo and feature parts. Now, Harold will give you a bit of a conclusion and summary here.
Thank you, Thomas. Thanks a lot. Okay, after all these demos, let's wrap up a bit. So you saw version 1.6 introduces lots of new features that want to further increase the value that you get from Visplore. Some of the highlights include new possibilities to join data sources via keys. You have seen new ways to segment data more precisely, also for segments with different durations, like these machine cycles. I showed you how to make use of the new scatterplot background feature, and there are also lots of additional improvements for data management, the conditions, the story feature of Visplore, and the usability overall. We hope very much that you find them useful and are already eager to try out some of them soon. When you have questions or comments, please get in touch with us. We do our best to help you in case you have questions, and we love to hear your feedback and inspirations that we can use for preparing future versions of Visplore. All right, and this brings us straight to the questions and answers part. So if you have questions already, please post them in the Q&A section of Teams. For this part, Thomas will join us as well.
Let's get here. Screen sharing, and we can see if we already have some questions coming up. Okay. So here is the first question that we can read. Can I draw and annotate in the process images directly in Visplore?
Basically, yes, you can use the sticky notes feature to add some extra text. And what you can also do is you can easily copy a screenshot of the data to PowerPoint first, for example, then draw some shapes around the data, and then export that image that you had back to Visplore. But in many cases, the feature was intended really for graphics that you have from a vendor, specifying, for example, lines where a certain asset is assumed to operate. So actually data that you get from a vendor.
Okay. Another question here is, are renamed variables also remembered when storing a Visplore file? Yeah, I can also quickly answer that one. So actually, yes, the renamings you make also for the imported attributes from PySystem, databases, files, whatever you save here, they are memorized as part of your templates. So what you can do, for example, is if you have an own naming scheme internally and some that you have from external customers, you can just rename these things, for example, and have your own templates that always use the familiar names for you. That's possible. And yeah, so that's stored as part of the templates. Good. One
more question. Are golden badges possible for multiple signals? Yes, you can define them for every signal. So you can already do this. And maybe as a bit of a outlook, we will further streamline the golden badge workflow in future versions. So for example, to set up bands for multiple signals at once. So this will be an upcoming feature of a future version.
Here's a good follow-up question, golden badge as well, if you want. Can I automatically check for the golden badge and notify the process engineer early? Yeah. So yes, one way how you can do this right now is already through our Python API, that you set this up to run, for example, in some regular intervals to check the conformity of these golden badges, and to then do something based on Python for an action, let's say notifying someone or writing something back. So this has been done in a way also by some of our customers already in such monitoring contexts. And yes, maybe also as an outlook, later this year, we will introduce a possibility to fully automate the data analysis on the most recent live data. And with this, there will also come, many other condition monitoring use cases to be possible without the need of some programming or external Python. But also now we could already help you with setting something like this up as we had it.
Okay, here is actually a comment rather than a question, but I would want to comment on this nevertheless. So one participant said he couldn't open the Visplore file in Visplore 3. Actually, because to some customers we rolled out Visplore version 1.6 already some days ago, the files that you create there require a new version of Visplore 3. This new version is online since today. Yeah. So with the version that you can download since today, you can open the stories that you saved in Visplore 1.6. And maybe for everyone who doesn't know yet, Visplore 3 can be used as a reader for your stories if you have embedded data. So if you create an analysis and log some insights store it with the data being embedded. You can share it with everyone, and they can just download our free version, Visplore free, in order to open it and still be able to do some interactive things like zooming there, selecting, and so on.
So since today, actually, you should get a little notification when you start Visplore free that there's a new version that you can download from there directly as well.
Okay. I have maybe one more question. Can I use the background for drawing a map of GPS data? Well, I can take this one. Essentially, yes. Yeah, so if you have a map of a city, for example, you can use this feature to indicate locations of certain assets. For example, imagine you have some probes that measure something scattered throughout the city. You can display a map of the city and have the locations of the probes for selecting them and so on. In most cases, the coordinates in such examples will be given as latitude and longitude coordinates of the assets. If the geographic region gets bigger, for example, an entire country, there might be some mismatches due to the difference between the latitude and longitude coordinates and the Cartesian coordinates of the image. Basically, at the moment, you could correct for this projection outside of Visplore, and for future versions, it's planned to also provide some integrated conversion of latitude, longitude to such Cartesian coordinate systems. But for small geographic region, in most cases, it will just work pretty well out of the box.
Okay, I think
it's almost 4. And actually, I think we have to conclude today's webinar. Questions that may not yet have been answered will be answered via mail soon. So it remains to be said, thanks to all of you for attending today's webinar until now. We hope we could give you some inspiration for your own work with Visplore. We hope you are all eager to try out version 1.6. And please reach out to us if you have any questions. It's a pleasure for us to answer them. So with that, we wish you a pleasant rest of the day. And goodbye from Visplore.
Thank you. Bye-bye.